This is the Chapter 3 test review for Algebra 2A, and this is the second part of this video. So the first part I did went all the way up through this, the end of number 3 here, which actually those 3 questions took up like 2.5 pages, but I'm going to start here with number 4 and then go to the end. Okay, so we're looking at y equals the square root of x, and it says find the inverse. Well, anytime you're looking for an inverse, we're going to start by flipping the x and the y. So x equals the square root of y. But then we need to get y back by itself. So to get that y out of that square root, I'm going to square on both sides, okay? And so that ends up being y equals x squared. Okay, so there's something a little funky about this graph in particular. This function says y equals the square root of x, right? When we talk about the square root function, typically we only include the top half, all right? Typically, we only include the positive values, okay? Which means when I graph y equals x squared, I need to restrict myself to that same domain. So notice that I'm only considering positive outcomes. And that's just because we're looking at this thing as the square root function. If I had wanted to include the bottom half of that, I would have had to put a plus or minus in front there, okay? But it wasn't there. So looking at this as the square root function, it's really just this top half, okay? Which means when I go to do the inverse, I know that y equals x squared is supposed to be a parabola, but when I'm looking at the inverse of this, I need to restrict it to only positive x values. Because, again, over here we were restricted to only positive y values. So my inverse is actually just going to be this one side of the parabola. It's going to be this right here. Okay? And actually I think they were supposed to intersect a little further up, but that's okay. Okay? So that would be the inverse function. Now, if you drew this with this bottom half in here, I totally get why you would. Okay, that's a mathematical rule that I don't particularly love. So if you had drawn that bottom half in there, then you would go ahead and draw the other side to this parabola. Okay, when you're talking about it as being the inverse of the square root function, we typically only talk about that one side. Okay, so is the inverse a function? Is what I drew there in orange a function? I would say yes. And there's 2 ways that I know. I could say because the original, which is y equals the square root of x, passes the horizontal line test. Or I could say that the inverse, which is the y equals x squared, passes the vertical line test. Either one of those answers would be correct, okay? But you do need to specify which one you're talking about, the original or the inverse, when you're talking about these 2 tests so that I know that you're using the correct one. Okay, either one of those answers would be fine though. Okay, so moving back to our friend y equals 1 over x, which we looked at, I think, in problem number 2. It says find the inverse, and the inverse of this one's kind of interesting. So when I go to find the inverse, I flip-flop them. So I go x equals 1 over y. And then I need to solve to get y back by itself, so I would multiply by y on each side. Okay, and so now I have y times x equals 1. And then I would solve for y, so I'm going to divide by x and divide by x. And I'm left with y equals 1 over x. That's weird. So the original function and the inverse are exactly the same. This function is its own inverse, okay? And if you wanted to know for sure, if you wanted to verify, if you plug this into this, you would end up with this, 1 over x. And then remember, anytime you do 1 over a fraction, it's really just doing the reciprocal of that fraction. So this would become x over 1, which is really just x. And remember, that's what you want to have happen for inverses, right? When you plug them into each other, it should be just x. So yeah, that's it. The inverse is y equals 1 over x. Let's look at that on a graph and see if we can understand why that's happening. So 1 over x, that's your hyperbola, right? Looks like this and like this. And remember, on a graph, when you graph the inverse, you reflect it over the line. Oh, sorry, phone's blowing up back there. You reflect it over the line y equals x, which is this line. If I reflect this function over that green line, it's going to land back on top of itself. That's how I know that this thing is its own inverse, okay? And is the inverse a function? Yes, because it passes both the vertical line test and the horizontal line test. And it's the same function, so it doesn't matter which one we use, okay? So yeah, kind of a quirky question. But I do think there's a question about that on your test, knowing that 1 over x is its own inverse, okay? All right, so now let's look at this next one. And this next one's asking about inverses as well. Okay. Switch x and y. So we get x equals 1 over y squared. And just like before, to get that y out of the denominator, I'm going to multiply on both sides. Okay. And so then I end up with y squared times x equals 1. And then I want y by itself, so I'm going to divide by x, just like I did before. And I'm going to end up with y squared equals 1 over x. But then the only difference here is that now to get that y by itself, I still need to take a square root. And I'm okay with us leaving our answer here. Technically, we should rationalize this thing, but I'm okay with leaving the answer here as long as we specify that this needs to be a plus or minus. Because when you take a square root when you're equation solving, you have to write it with a plus or minus. So I would say plus or minus square root of 1 over x. Okay. So graph the parent function and the inverse. So the parent function we already looked at looks like the side-by-side hyperbola. Okay. And then I'm hoping you can visualize what this thing would look like if we flipped over that diagonal line. Okay. That diagonal line is going to cut that top branch in half, right? So this piece is just going to land back on top of itself. This piece is going to like fold in half. But this will end up down here. So we'll end up with our other branch here. And then when I look at this, is this thing a function? So now my new function is really this branch and this branch. It's these two, okay? So this is the, let's see, I should probably mark this for those of you who are just going to be looking at the answer key. This is my original, is those two branches. These two together are my inverse. So is the inverse a function? Well, looking at this, if I were to draw vertical lines in here, I hit the function twice, right? So no, and based on what I just said, I would say because the inverse fails the vertical line test. Okay, and really from looking up here in the equation, I can see that when I plug in one x value, I'm going to get two different y values because of that plus or minus. Okay, I also could have answered this question by saying, hey, I knew that from looking even at the original graph because that was not going to pass the horizontal line test. So I could say the original graph or the parent function fails the HLT. Fine with either one as long as you specify which is which. Okay, some spacing got messed up here, but find the inverse of this guy. All right, so just like before, x equals 2 over y minus 3. So for this one, I would multiply this entire fraction just to get rid of that denominator by the quantity y minus 3. Multiply by that whole thing. I would not go ahead and distribute here though. I mean, there's ways you could do it by doing that, but I would leave this over here as x times y minus 3. And then you have just equals 2. Trying to get y by itself, so just like in the other ones, I'm going to divide by x right now. And that's going to leave me with, this is gone, so y minus 3 equals 2 over x. and then I would add the 3 to the other side. So plus 3, plus 3. And so I end up with the equation y equals 2 over x plus 3. Okay, that's my inverse. And it didn't want me to do anything else with that. Just that's the inverse. By the way, I kind of wrote it that way because I was pinched for time, or not time, space. Really, this would have been a better way to write it because you want to make it really clear that that 3 is not supposed to be part of this fraction, right? So the 2 over x should really be kind of separated from the 3. I just didn't have the space to write it that way. Okay, what transformation rule maps the absolute value function to each of the following? Okay, so this one is, I can tell it's a size change. And again, I'm not so worried about you writing this first part here. Okay, oh my word. Look at what's happening to the x. In the equation, it's being multiplied by 4, right? So in our rule, we would say divided by 4. For the y, we need to remember that that 5 really belongs over here with the y. We moved it over. Someone moved it over at some point to get the y by itself. But really, this should be like divide by 5, divide by 5. And in the equation, it would look like y over 5. And then if I do the opposite of that, it would be 5y. So I've said this a couple of times, but when people move that y number back over to the right-hand side, and then you're trying to put it in a rule, you can kind of just go with whatever's over here, right? Because it's already been flipped when it moved to this side. Okay. So looking at this one, this is a transformation. So txy maps to, and let's see, the x is subtracting 8. So in my rule, I would say that we're adding 8. And then the y, if you picture the 7 going back over with the y where it belongs, it would be a minus over there. So we're going to write it in here as a plus. Okay? And that's it. Those are my transformations. All right, I'm unsure about the wording of this next question. Prove that the following are or are not inverses. Essentially what I'm asking you here is, are they inverses or not? And then justify your answer. So remember, the best thing to do would be to do the composite, to plug one into the other and see if it works out to be just x. Okay, and really I should check both. I should check both directions before I make my final conclusion here. So I'm going to start by plugging this function in over here. Okay, so that's going to look like this. 5 times 2x plus 3 over 5 all over 2 minus 3 over 2. Tried to get all those fractions inside fractions there. I can see right away that these 5s are going to cancel, which is kind of nice, right? And so then I am left with 2x plus 3 over 2 minus 3 over 2. And then I think what I'm going to do here is write these two things separately over the x, okay? So I'm going to write this as 2x over 2 plus 3 over 2 minus 3 over 2. Watch what's going to happen now. Is the 3 over 2's plus 3 over 2 minus 3 over 2 gone and gone. And then 2x over 2, the 2's are going to cancel. And lo and behold, I am left with just x. Okay, so this direction worked out the way I wanted it to. To truly verify, though, I need to go the other way as well. So now I'm going to take this, the 5x over 2 minus 3 over 2, and plug it in for x here. Okay, so let's see what that mess is going to look like. So it's going to be 2 times 5x over 2 minus 3, over, of course, not an erasable one, 3 over 2. And this is all over 5 from this original function. Well, the nice thing that I see happening here is the 2, and the 2 are going to cancel. Like if I distributed this 2 in here, this 2 and this 2 would cancel, this 2 and this 2 would cancel. So then I'm left with essentially 5x minus 3 over 5. Oh, let's see. You know what I did back here? I did 2x. I forgot the plus 3. Maybe some of you were silently yelling at me for that. So this should really have, so from back here, this should have a plus 3 on the end, right? So I should have a plus 3 sitting here. Okay, I thought that wasn't working out the way I expected it to. So now, looking at this thing, the minus 3 and the plus 3 are gone and gone. Then I'm left with 5x over 5, which means the 5 and the 5 are gone. And again, I'm left with just x. Okay, so I would say yes, these things are in fact inverses. Okay, so if you got everything in that packet, you're in pretty good shape for the test. There are a few other types of questions that I want to make sure you see, and so that's why your next assignment will be the PST and the chapter review. Just a reminder that the PST assignment is an actual assignment. It's required. The chapter review are always problems that I go through and look for things that are similar to what's on the test, but you don't necessarily have to sit down and do every single one of those problems. That's meant to just be a sneak preview for you. So I would pick any problems out of that review that you think you might struggle with and give those a try. Okay? And I will see you in class on Thursday.